Hi, I'm Rebecca Clamerger, Associate Professor at Northeastern University, where I direct the Interact Animal Lab. Last spring, I designed and taught the first ACI class at Northeastern in partnership with Dune New England. It was a great experience with a group of talented students, which led to several emerging work being presented this year at the ACI conference, including the Curio Cabinet and listening to the fishes. Today, I'm presenting one of those works, Swing on It, on behalf of one of my team, my student, David Mohamed, Sean, and Amr, as well as my collaborator, Sarah Woodruff, Animal Wellbeing Advisor at Zoo New England, and Ileana Harsky-Douglas from the University of Glasgow. So I'll walk you through the rational design process of our pilot deployment and how this project might evolve into a broader platform for non-food-based sonic enrichment for primate and small mammals. So the goal of the class was for each team to envision new ways to leverage technology to enrich animal lives in ways that are meaningful for the animal and realistic in the settings that they live in. For this specific project, we worked closely with a team at Stone Zoo to define a set of design criteria. First, the enrichment had to be non-food based. Second, it needed to support animal agency. It also needed to, of course, meet safety standards. And finally, it had to fit smoothly into the zoo's daily routine, and it had to be something that keepers could potentially manage on their own. For this project, we worked with the Colobus monkey at Stone Zoo, a small family group of arboreal primates. They live in a mixed indoor-outdoor habitat, and the care team already provide daily enrichment, gave us a chance to design something that could fit into the existing rotation. These monkeys aren't very food motivated, so we focus on the systems that support physical engagement, not something that was reward based in terms of food. And so our goal was to explore different possibilities for acoustic interactions. There's been growing interest across ACI in the role of sound in animal enrichment, specifically in systems that go beyond passive playback. In my lab, we've looked at this through various lenses, mainly animal gaining choices and control over their auditory environment. For example, of 2020 CAI paper on musical control for a parrot at the San Diego Zoo, which shows that the bird learned to use sound both as enrichment and as a way to modulate visitor attention. There's also been great work in Ileana's lab on lemurs and giraffe interacting with audio system, explaining how animal can control and respond to auditory stimuli. I'm also part of the Acoustic Enrichment interest group who are looking at how controlled sound exposure can support welfare and engagement across species. Of course, it's important to acknowledge the potential risks of noise and sound on animal, but also some of the potential for them in well-designed interactive acoustic systems. So design evolved substantially over time. Our team first explored suspending ropes, but for safety reason, we moved to using swing as those type of items are already approved and in use. And we're still iterating on possible future species-specific improvements. But the idea of building on familiar structure gave us more practical, low-risk design that could easily fit into their daily routine. And of course, there's always a tension in zoo-based work between naturalistic design, safety, and visitor perception. Even small design decisions need to navigate institutional culture and what's considered appropriate or educational for the public. Beyond aesthetics, there's a real risk when visitors see animals playing with different devices. It could unintentionally reinforce the idea of animals as pets, which in turn connect to the broader issues of illegal exotic pet trade. So every design choices here are to balance interaction, welfare, and the way the public might interpret what they see. After 5 months of iteration and discussion with the husbandry team, this is what the final design looks like. We use an approved swing with low risk of strangulation, attached a waterproof pelican case at the bottom of it, which holds a Raspberry, battery, and IMU sensor, as well as a wireless speaker. And outside the habitat, there's a second Bluetooth speaker to give it a chance to hear what's happening inside. And everything is managed through a simple web interface used by keepers. They can log in, choose audio stimuli, turn each speaker on and off, adjust volume, and change parameters. The system is fully wireless, portable, and can be deployed both indoor and outdoor, depending on the season. And the experience looks like this for each stakeholder. The keeper configures and controls the system. When the monkey uses swing, move, swing, um, it emits sounds inside the enclosure. And at the same time, some sound are also played for the visitor outside. So as I mentioned, the system was designed to be very much a modular platform, meaning that both the interaction model and the sound content can be adapted over time. Zookeepers were especially interested in the idea of being able to upload their own audio file and adjust the motion map, how motion maps to sound. And for this initial use that we made here, we proposed using only natural sound um, without any co-specific calls, and an effort coupled model where swing intensity controls how many layers of sound are active. At low motion, we hear stream, then insects, then birds at higher level. Again, the idea is to give the monkey control over the soundscape through their own movement, but in a way that's gradual and ambient. So here are footages from our pilot deployment, which was done without any audio, with two objectives. First, to see how and if the monkey would use a swing, and secondly, to measure the swing amplitude to use for our calibration. So the paper really focuses on the design process, the prototype, and the rationale for using the system as both enrichment tool and potential research platform. And the system has not been yet fully evaluated, but we've developed a three-phase evaluation prototype to guide this next step. First, we would work on the baseline phase where the swing is silent and we log natural use, a little bit like the pilot that you saw. Then an intervention phase with a musical swing run during selected session. Finally, a routine use phase where keepers on the longer term choose when they want to activate it as part of their normal enrichment rotation. So this is also good data to see if the kind of deployment we do have potential long term. And across all phases, we combine sensor data from the swing with video documentation and qualitative observation from keeper to assess engagement and usability. So in terms of limitation and future work, this is a single-use, single-species case study, which gives us a chance to go deep into the design implementation, but of course that limits immediate generalizations. One open question is around sense making. It's never guaranteed that animal will connect their action with the resulting system response. So we still need to observe how quickly and reliably the association might form, and what kind of, and that kind of evaluation is actually very complex. So we've started to have strong tools to understand this kind of things. The system itself being modular, it could be adapted to other arboreal species, but again, each case would need its own behavioral grounding and safety review. And more broadly, this work is really part of thinking of treating zoo animals as active users of technology with design that increase choice, agency, and environmental control. So I'd like to thank our collaborator at Zoo New England, especially Sarah Woodruff, Bill Robles, and Pete Costello, and the entire zookeeping staff who were very generous of their time and expertise. Also thinking of my co-author and collaborators on this project.